Hello guys, let's continue with our secular measures. So you see, even though the chapter is known as secular measures, right, you will come across a lot of triangles in the chapter. Quite ironic, but yep, there will be a lot of triangles, right? So the chapter is actually related to solution of triangles from Form 4, right? But let's look at a few examples so that you can understand how to solve these triangles. Here we have figure shows the triangle ABC and question A they said calculate the angle theta and also calculate the area of ABC. Okay, so you can calculate the angle theta using the traditional ways are very difficult here, right? So the easiest way to calculate the angle theta here is using the cos rule from solutions of triangle, right? Hope you remember cos rule. If you don't, then just do a quick revision, right? I can show you an example here, right? How do you calculate the angle theta? If you want to calculate the angle theta, the formula you must start with this. And if this is A, capital A, this will be small letter A. This will be small letter B, this will be small letter C, right? And since we want to calculate the angle which is near A, the formula will start with A square, where A square will be equals to the other two, B square plus C square minus 2BC cos the angle there, which is theta. Usually we can also write capital A there, right? If you are wondering where this formula came from, then clearly you have to revise the chapter solutions of triangles, right? So substitute the values. So A square will be 9. A is 9. So 9 square equals to B is this 11 square plus C is 10. 10 square minus 2 times 11 times 10 times cos theta. Now we have to calculate theta. Actually, when you are good at this, you can straight away calculate theta, right? But let's say you're not an expert yet, then you do it slowly. What you do is you move these things first. So what you have here is 9 square minus 11 square minus 10 square equals to the other stuff will be still here. See, the common mistake people make is that they calculate 11 square plus 10 square minus all this. You cannot actually minus all this because these numbers times with cos theta. You cannot operate this, right? So once you have moved everything here, then all these things you bring and divide. So what you actually get is 9 square minus 11 square minus 10 square divided by negative 2 times 11 times 10. So what is left here will be cos theta. Now from there, we can straight away calculate theta. What we do is type this out in the calculator, get the value, and then shift cos. You will get the angle theta. Let's see. So open up fractions. Right, so 9 square minus 11 square minus 10 square. Go down, negative 2 times 11 times 10. You press equals to. So this will be the value for cos theta. You want theta, so you do shift cos. Answer equals to that 50.48. Now angles we take 2 decimal places enough, right? So this will be 50.48 degrees, right? That will be your angle theta, right? Now the area of ABC. To calculate the area of ABC, there's also a special formula from that chapter, solutions of triangle. Once you know this angle already, 50.48, you can very easily calculate the area by doing area equals to 1 over 2. You have to use the two sides that make the angle. So 1 over 2 times b times c times by sine theta. So you use the two angles and then you times by the sine theta times by half, right? So in this case, the area will be 1 over 2 times how much is b? It's 11 times how much is c? It's 10, and sine theta will be sine 50.48, and then you just type that out in the calculator. 1 over 2, you can just press 0.5 times by 11 times by 10 times by sine 50.48. You press equals to, that's the area, guys, 42.427. Now since this is not an angle, we take 3 decimal places. 42.427, and the unit should be centimeter square, right? So you see all these formulas we got from Solutions of Triangles, the chapter from Form 4, right? So if you find all these too difficult, then you have to revise that chapter, right? You have to know this because this is very, very useful in this particular chapter, right? Let's look at another example. Actually, I do not know whether I should make one long video explaining everything or many short videos explaining concepts, right? So maybe you can tell me. Right, number 2 here. Right, see, this is more likely in chapter Circular Measure, right? Where we have an isosceles triangle. Isosceles triangle means, two of the sides have the same length. Why? Because usually this will be part of a sector where this will be the center of the circle, center of the sector. So these two will be the radius. So the radius will be the same. That's why 9 centimeter, 9 centimeter. And the symbol here is O. See, that is a problem too, because, here we want to calculate the angle theta in radians. So we want the angle theta in radians. So later we have to convert the angle in radians because the formula, the cos rule formula uses angle in degrees. So after getting the answer, we have to change it to radians, right? And so when you want to write down the formula for question A here, when you want to write down the formula, right? So you want to find the angle theta. So the formula, you must start with the length of this, which will be O square. See, when you start the formula with O square, you see O is a very, very terrible symbol to be used, right? Because it looks like 0. So in this case, instead of writing O square, we just use the old-fashioned way of mentioning this side, which is PQ. So we just write PQ square to avoid using O square. So PQ square will be this one square. This one you can use P, no problems. So P square plus the other one will be Q square minus 2PQ cos theta. So similar to just now, PQ square will be 12 square equals to P square will be 9 square plus 9 square minus 2 times 9 times 9 cos theta. We can do the same thing like just now, but this time let me show you how you can straight away get the answer for theta. So what we do is we do the shifting calculation and all that using our calculator. Right, so it will be 12 square minus 9 square minus 9 square, because bring all this here, right? Get the answer first and then divide by bracket negative 2 times 9 times 9 close bracket equals to, that will be the value of cos theta. So now you want the angle, shift cos, answer equals to 83.62. 83.62, right? So the angle theta will be 83.62 degrees, right? But we want theta in radians in this question, so we have to convert that, right? How do you convert degree to radians, right? So theta will be 83.62 degrees. Remember from earlier videos, you have to times by pi over 180. So theta will be 83.62 times by 3.142 divide by 180, and you get 1.634. Oops. Oh, I mistyped. So 83.62 times 3.142 divide by 180, you get 1.460. 1.460 rad. Yep, that will be angle theta in radians. Right. Now to do the question B, since we know the angle already, we want the area of POQ. Okay, that's a perfect question actually. So question B, area of POQ in this case will be 1 over 2 times P times Q times P times Q times by sine theta, right? See, I call this the perfect question because here I can point out, right, that the angle theta you must use in degrees. You can't use radian. Even though in this question they wanted theta in radians, in this formula you cannot use the angle theta in radians. Right. If you remember from the earlier videos, we learned two new formulas, which was length of arc equals to theta r, and area of sector is 1 over 2 theta r square. Now, these are the only two formulas where theta will be in radians. All the other formulas that you use, theta must be in degrees as usual, right? So here we have to use theta in degrees. So this will be 1 over 2 times P times Q will be 9 times 9 times sine 83.62, right? So that will be 0.5 times 9 times 9 times sine 83.62, and you get 40.249. 40.249 centimeter square. Yep. You know, if you know all this, the chapter will be so much easier. Let's look at another example. Right. There we have another triangle. And in this triangle, we want to calculate the length of MN, let's say. The angle is given. You see the angle is given. Right. But we want to calculate the length of MN, let's say. Calculate the length of MN. Right. So again, we can use the cos rule. But the symbol for this will be small letter O. Since this is O, probably this is the center of a circle. So that's why the symbol is O, but we don't want to use O in our formulas, right? So what we do is we write as mn square equals to m square plus n square minus 2mn cos theta, right? And mn is what we are looking for, right? So mn square will be, m is this 17 square plus n is this 17 square minus 2 times 17 times 17 times cos 48 degrees. Now to find mn, we have to calculate all this and then square root the answer. So it becomes 17 square plus 17 square minus 2 times 17 times 17 times cos 48. You get the answer and then square root the answer. you get 13.829. Yep. So Mn is 13.829 centimeters, right? Yep, all these are from solutions of triangles, and they are very, very useful in chapter circular measure. I'll see you in the next video, guys. Don't worry, I will help you out.